that's where we're going to start. Balancing oxidation and reduction. Where is that? Is that further down? Here it is, right? There we are. Okay. Caroline, you need to answer the question first. How do you balance oxidation-reduction reactions and acidic or basic solutions? What were the steps? What'd you do first? No, it's not allowed. What do you do first? Anyone help her? Balance everything but O and H. Okay, Priscilla, you balance everything but O and H. Then what do you do? Oh, we actually kind of skipped something. First, you got to divide it into its half reactions, the technical jargon. Yeah, we kind of forgot that. Divide it into its half reactions, then balance everything but O and H. Now, Priscilla, then what? Balance O's by adding H2O. Okay. Alyssa, then what?
Then you
balance the H's by adding H pluses. Monica Soto Ruiz, then what? Do the E negatives. You add them to the most positive side. Okay, Summer, then what? Put it all together. We have to add up the two half reactions so that what cancels? The E's. That's the game plan. Okay. So, Eric, what would you do first?
Set it to where Cr2O7 negative 2 yields Cr plus 3.
Good. That means the other half reaction has to be this dude, right? Chlorate going to perchlorate. We're going to add that stuff up, get our final answer. Okay. So, Monica Lopez. Let's balance the top half reaction first. What are you going to do first? Oh, you fall in the same trap as me. Don't skip that first step. The chromiums aren't balanced. I put a 2 where? In front of the Cr plus 3. All right, now the chromiums are balanced. Now we can do what Monica said in the first place, Kelly, which was what? Oh. Balance the, yeah, so that's done. The chromiums are done. Let's just do the top half reaction. So balance the O's, you said, by adding to which side? Reactants or products? The products, and how many? 7. Good deal. Now stop us if you're not sure how the heck we're getting this. Paul, now what? Yes, Summer.
So, if those on one side, you put the H2s on the other.
Yes. That's the only way that's allowed to balance. Yeah, if the O's were over here, you got to add them over there. Just so the same number of O's are on both sides. That's all we're trying to get. Right? So we have 7 O's, 7 O's. Make sense? So stop us. Good. Paul, now what? Okay. Was that enough? It'd be 14 because you have to get the number of them, multiply the coefficient times the subscript. 7 times 2. You have 14 H's over here. Yeah. It's kind of like if you found the molar mass of H2O, you'd balance and you'd add up an O and how many H's? 2 of them. Well, you've got 7 H2O's. So you have to multiply that 7 times that 2 to get the total number of H's. So it's not 7 over there, it's 14. Okay. Now I think it's the most complicated part right now. And that's this charge. April. The charge on this side. Let's start with just the this part. What's the charge there? Not 10. What's the trick to doing this? Just take the coefficient. It's 14. Take the coefficient times the charge. Every single time that works. take the coefficient times the charge. Now, if nothing is written up there, it's 0. That's the weird thing about charge, I think. Like, look at this, H2O. Nothing is written below that O. Usually that means not 0, that means 1. But with charge, it's very odd. If nothing is written, the charge is 0. But that's why it's plus 14. You have to take 14 times a positive 1. So this is plus 14. Okay. Jesus, the charge here. Take the coefficient times the charge. You'll get it. Negative 2. 1 times negative 2. Negative 2. Okay. My whole side over here, Jasmine. This whole side is what now? Positive 12. I've got positive 12 on that side. Okay? That's all you do to get the charge. Multiply the coefficient times the charge and you'll get that part. I'm not sure what your question is.
You know how it was like last time that we were doing negative 2 over this?
Oh, that's oxidation states. That's a different game. We'll play that game next. Right? I think we'll do that game next. Okay? Okay. So positive 14. It's a whole different game with oxidation states. Whole different game. Okay, so you have a positive 12 on this side. The other side. Aaron, what do I have right here? Plus 6. Caroline, right here, I've got no charge. So 7 times 0, which would be 0. 7 times 0, 0. Okay, so this whole side, I've got 6. Where did I get the 2 right here? Okay, that was the very first step. First we split it into its half reactions, then you balance everything but what and what? O and H. So you got to check that. 2 chromiums, only 1 chromium. So you got to put a 2 there. That's where that came from. Good. Okay, so now okay, Alyssa, we figured out the charge on both sides. Not balanced. What do you got to do?
You add a 6e minus to the side so that the charges will both be plus 6 and plus 6.
Did you hear? Now, she added the e minuses to the most positive side. So pretty much when I'm doing this, I don't screw up. I just look at the sides. Positive 12, positive 6. Pretty easy to pick out. This guy's more positive. Slap down the e minus over there. Okay. Now, you could just add it. A negative 1 and positive 12 is positive 11. See, and then you find out you're not going to 0. You're going to 6. Okay, so I need a bunch more. Then you do it. Alyssa jumped right to it. She said you have a negative 6 and a positive 12 gives you a positive 6. So that's why she said throw 6 negatives on there. Okay? But do it stepwise if you want. Figure out what's the most positive. Okay, I'm going to put the e minuses over there. And then just figure it out. You know, one step at a time.
How do you decide it?
You have to figure out the side that's the most positive. And then each E negative is only 1 negative. Remember, to get the charge, it's the coefficient times the charge. So this is a negative 6. So negative 6 and a positive 12 is a positive 6. I better hope there's a positive 6 on the other side. There is. So we got it. Okay. So this guy is done. Oh, I put the 6 in the wrong place. All right? Doesn't it go down? What am I doing here? Oh, it is right. It's all these different colors are really confusing.
I thought it was on the purple.
Am I doing the purple?
Yeah.
It is. I did stick it in the wrong place. All right. Now, let's clean this up. Make it look better. You're right. I'm doing the purple. All right. Clean all this
What
up.
happens to that 12? Is that like later on?
Well, we don't care. We needed that positive 12 because now we're balanced. That's all we want. It doesn't have to be 0 on both sides. It just needs to be the same on both sides, so it's balanced. That way, if we multiply through by some number, it'll stay balanced. As long as we do it to both. We'll multiply through by the whole thing.
So basically, you subtract the bigger the charges.
Yeah, I just keep...
Left, just put it on the most positive side.
Exactly. Whatever's on the most positive side, that's where you add the E negatives. And you keep adding them one by one until they get to be the same on both sides. Okay, the bottom half reaction. Aaron, now what? Let's balance the bottom half reaction. What would you do first? Or Aaron. So I was looking at Paul for some reason. Aaron, what would you do first? Balance the... Technically, you should balance what first? The chlorines, right? But they're good. They're good. So leave them alone. So Summer, what would you do then? Chlorines are done. Perfect. So balance the O's with H2O, she says. So you put H2O where? Reactant or product? Why reactant? 4 O's? 3 O's? Yeah, we're short on the reactant side. And we're short exactly 1.
So you have 1.
Just one of them. Just one of them. Okay, keep going, Eric.
Did you have the electrons already?
No, we just balanced the O's. What's after balancing the O's?
The H is the other side.
So how many and where?
You need
2 H's on right over here.
2H plus.
Looking over here. Make sure you check this guy for H's. None there. All we have is 2. He's right. Just put 2 over there. And it can't be H's. It has to be H plus. That's another big deal. Okay, Monica. Let's do that charge. Monica Lopez. Oh, let's pick a different color. I don't know about this orange thing. Okay. Right. Yeah, it's green again. That's okay. What's the charge there? 0. Here, Monica. -1. So my whole side there, my whole side here is -1. Okay. The product side, Kelly, right here I've got -1. Right here I've got +2. So the total is +1. Okay. So Paul, I've got a -1 on this side. I've got a +1 over here. Okay, let's throw one E negative over there. Check it before you move on, though. 1 times -1 and a +1 is 0. Doesn't match. Need some more. That's all it means. Don't give up. It just means you need more. 2. Try it. -2 times -1. -2, +1. Add them up. Get a -1. Works. We got it. Okay. Clean her up again. Oh my gosh. Getting out of there, getting out of there. Okay. April, what do we do now? Cancel out the common stuff. Yeah, but you're supposed to go by what, though? The one thing you really have to cancel is the what? The electrons. So you multiply through by something. It's got to be what? Yeah. You hear what Alyssa said? Multiply the bottom one through by 3. That's your only guide. Yeah, you're going to be messing with canceling hydrogen ions and water, but that's not what you go by. You got to get rid of those electrons. 3 times 2 is 6 electrons. 6 electrons. This is going to work. All right? Now, I think it's a good idea. At least I don't seem to screw up as much. I go ahead and I put these coefficients in there. A 3, a 3, a 3, and a 6. Right? And then everything over here, you put right here. Everything over here, put right there. And then you can simplify it, right? But I would just stick it all over there. So I've got, I add this up, I've got, just write everything down. 14 H's, this Cr2O7 negative 2, 3 H2Os, 3 ClO3s. I'm just copying it exactly as written. The top one and the bottom one. Order does not matter. Because now I'll get a couple points taken off. Why? At least I got most of it done. It's not simplified. Yeah, I can cancel. Oh, the H2Os, yeah. I can get rid of all of them. Cross out that whole thing. Right, cross out this whole thing and change that 7 to a 4. I could also cancel the H pluses. Get rid of all of those. Change that 14 to a 8. Now, if you write neat, I wouldn't take any points off on that because I can see exactly what it is. That's 4 H2Os, right? Okay. Now, let's jump back to this. And let's ask Jesus, how do you determine oxidation numbers? Jesus, how do you determine oxidation numbers? There's a bunch of little steps, I think, but what's something that you did? Add up all the oxidation states of everything. Has to add up to be the charge. That's a biggie. That's a biggie. Okay. There's some other biggies. I think there's only like 2 more. Another one, Jasmine. What's another one? Jesus is right. Add up all the oxidation numbers, like this guy. Add up 2 ALs and 3 S's. You better get the overall charge. What's another one? Anyone help her? Oxygen is always -2. I think there's only one more. H is always +1. Okay? Now, all of these things, what's the charge on every single compound up there? 0, right? Because all you do look up here. Right? So what the other class liked, and I assume you guys aren't any different than other students, let's not break it up. I thought breaking up was a good idea, but they don't like breaking it up, so I don't think you guys will either. Just leave it alone. I think, see, someone should have told me that days ago whenever we did this. Leave it alone, and let's just figure it out. Let's start at the top here. Li2SO4. So where would you start then, Caroline? Okay, slow down. How does she know lithium is +1? She can look up here or look at the formula, right? Where does the 1 come from? If you put parentheses around polyatomic ions, you can see that's a 1 right there. Okay, but that's where it's coming from. Okay, so lithium has to be +1. Priscilla, what else? What would you do next? Oh, why did I circle the +1? That's my answer for lithium. Yep. Priscilla, what would you do next? Over the O. Put a -2 over the O and circle it because that's your answer. You quit right now. You've got 2 out of the 3. You're done. You just, you have most of your points. Alyssa, now what?
You take the -2 times it by 4.
Oh, Okay, take the -2, she says, take it times the 4, you got a -8. Well, keep going. You're doing good.
And then you see that if you have the +1 on lithium, then you have some lithium plus the sulfur has to equal 0.
Okay, you're so close. The lithiums and the sulfur and all the oxygens have to add up to be 0. But the lithium isn't just +1, it's +2 because you have 2 lithiums, right? And that was our convention. Is up on top we write total charges, right? So 2 times a +1 for the lithium. Where am I getting the 2? Right there. I have 2 lithiums. 2 times a +1 is +2. So sulfur has to be, right, what number would you write right in there? What +2, and then I guess you're asking what +2 gives you 8. I mean, gives you a right? Because you have to add it to be 0. 6. 6 plus 2 and a -8, add it all up, you get 0. Sulfur's got to be 6. How about, Aaron, how about this next one? Calcium chloride. Calcium's got to be +2. Man, you're halfway there. Monica, so do Ruiz. Cl's -1, right? You know that's its charge. And we can do the math to prove that this is going to work out. 2 times -1 is a -2, a +2. It works, but you really don't need to. Yeah, you can go 2 routes. One is it's in group 2. Or it's so much faster just to look at the formula. The subscript on the chlorine is a 2, so it has to be +2. Remember you do the diagonal with the charges? How about the next compound, Summer, this one, C? What would you do first? Okay, O is -2. That works. Always works. Keep going, Eric.
PB is +2.
Good. Key. PB is +2. Okay, we're not breaking it up, Monica Lopez. We're not breaking it up into its ions. We're going to do the whole thing together. So keep going. Multiply the -2 times 3. Okay, you get a -6 there. Keep going. You're doing good. The lead total has to be +2. Okay, this guy's got to be 4. But be careful. This is... What's the answer for N? Is N +4 or is it 2? N is 2. This is the trick. This is the problem with not breaking it up into ions. You got to be really careful and recognize, oh, how many N's do I have? The 4 is right. I think everybody agrees with the 4. Right? A 4 and a 2 is +6. Add it to a -6, you get 0. No question really there. But the answer for N is +2 because you have 2 N's. Right? See the little 2 outside there? You've got 2 N's. So each N has to be +2. So you got to circle the +2.
So if the 2 on the outside,
They should be a 12.
yeah, because it's on the outside.
2
times. Oh, we did our math wrong. We did our math wrong. Oh my goodness. We did our math wrong. How many O's do we have? We have, how many O's do we have? 6. We got 6 O's. So now the total charge isn't, total charge is -12. Ouch. Okay. What Eric said still goes though, right? +2, +2. So what plus a 2 and a -12 gives you 0? +10. Divide it by 2, you get 5. Yeah, we have 6 O's. Didn't even notice that. Yeah. Okay, let's try it again here. How about D? Kelly, where would you start? Okay, good. O is a -2. Keep going, Paul. Chromium's 3. April? H is always +1. I mean, we can do the math, but we really don't need to, because H is always +1. We can do the math. 3 times +1 is +3. 3 times -2 is -6. It works. Okay. We didn't really need to do it. All right. If you can do E, I think you really got the idea here. Jesus, where do we start? Perfect. Excellent starting point. Caroline. Oxygen is -2. Priscilla. Okay, you want to write a 6 above the Fe, right? Is that what you mean?
Yes.
Okay. Alyssa.
And then for the O, you have to go to the multiplier out, so it'd be total of -24.
Yeah, isn't it -24?
Yes.
You got to take the 3 times the 4. So you really have 12 oxygens. Each one is a -2. That's -24. So I need an 18. HS has to be 6. I think you got the idea. Right? Okay.
What happens to that? So on the iron,
Each iron is a +3. So the total is a +6 for the iron. Well, remember you divvy it up. All these guys have to add up to be 0. The iron alone is a +6. The oxygen alone is a -24. Just due to the S, you got to have a +18. So that's how you take into account the iron. It is taken into account. Otherwise, you're not going to get the 18. Okay. I don't want to ask Aaron again. Let's ask Monica. Monica Soto Ruiz. Whole thing. What's the next thing that looks the most uncomfortable to you? Or does anyone have a real solid answer for this? You feel strongly about something.
can we do the what is the efficient molar concentration?
Molar,
On the
oh,
last page?
okay, the last page. Let's jump down to that one.
Because I don't completely understand that.
Okay. What is the equation for molar concentration? I give that to you. Moles per liter. What's the equation for a dilution problem? I'm just answering the questions first before we get started. All right? MIVI equals MFVF. How do you know when to use a dilution equation or a molar concentration equation? What was the hint? Yeah, 1 or 2 molarities I think is easiest. Okay, let's answer this first one then. Summer? Which equation are you going to use? Yeah, M equals moles over liters. That is the real starting point. Recognize what equation. Do you see why she picked it? Yeah. Okay. So Eric, now what then? Which one of these are we trying to solve for?
You're trying to solve for the 1.2 bit.
I guess what I'm trying to say is
No.
which one. When I say 1, you got to pick either big M, the moles, or the liters.
The volume, the liters.
We're after the liters. This is the one we're trying to find. And then once we get it, we got to convert to milliliters because they want milliliters. Okay, so we're after big L. Monica Lopez, we got to know big M and moles. What's one of them? Well, just plug in numbers for big M or mole. 1.25 is the big M. Kelly, they had to tell us the moles. There you go. Convert those 45 grams into moles. Okay. Oh, oh, thank goodness. It just says G. If it did say kg, we have to convert it into grams first. Okay. So, Paul, I need the molar mass of H2SO4. You tell me what to add up here. Oh, it's K2SO4. Man, what's going on here? That should be a K. Okay, I need, so 2 times what? Oh man, it's way over. Probably easier for me to read than him. About 39.1 plus 1s, about 32.1, right? Plus 4 oxygens, 4 times 16. So I get about 174.3. April, we don't want to mess up here. Where do we put the 174.3, top or bottom? Bottom. You got to get those grams to cancel. Okay. 1 over. About 0.258. Okay. Jesus, we got this far. Oh, you don't want to screw up with the math. How are you going to get the big L? Yeah, he's right. You hear him? He moved. He recognized the diagonal story there. He's moving the 1.25 on the bottom. He's moving the L up on top. I don't know if you heard him. He said take the 0.258 and divide it by the 1.25. That's how he got it. Right? He moved the L up on top, moved the 1.5 down. And you take that. Yeah, that equals liters, though. So we're not quite done. Divide it by 1.25. About 0.21 liters or so. And then you have to multiply or divide by 1,000. Multiply. So you end up with 210. So your answer should be about 210 milliliters. Okay. Okay, I think 12 looks similar. Okay, how about, let's let, okay, we've got 12, 13, and 14. Let's let Jasmine pick here. Which one looks the ugliest to you, Jasmine? 12, 13, or 14? 13, she says. Okay, we're going to do 13, Caroline. These concentration questions always start with the same thing. You got to pick out what equation you're going to use. She's right. Does everybody agree with her? All right. So Priscilla, we've got 4 variables here. Which one are we going to be solving for? It's the VI. In fact, it's pretty much always the VI, right? I don't know if you notice that. That's the VI. Okay, so that means we have to know air and everything else. So leave VI alone, I guess. What's MI? The 3.5. A trick to doing it is what you're going to prepare are always the finals. The final is always 2. It's a smaller big M because it's dilute, so it's a smaller big M. That's another hint. But you have the 3.5 big M. And the finals we said, so that has to be the 1.5 big M. VF, everybody, has to be? Okay. Do I need to convert that to liters? Do you remember this? Right? Whatever units this guy is in, he will be in too. So if you want to convert to liters, fine, but then your answer is going to be in liters. It's fine. Doesn't worry about it. It's very different than this equation. You don't have any choice. This has to be liters. Okay?
So you don't need the percentage.
I know. Is it just there to confuse you? You're never going to use it. Okay, so VI. 1.5 times 50 divided by 3.5, about 21.4. Okay, we've got 30 seconds, Alyssa. How do you say your answer? Take 21.4 mils of 3.5 molar and dilute to 50 mils to get 1.5 molar. That's it. Did you catch all that? I would just write this and then erase stuff. Take VI of MI and dilute to VF to get MF. All right? Now that's not going to work. You're going to get points taken off. You have to erase VI, put in VI, erase M, right? It'll work. Okay. So Smith does not have lab this week because the folks on Thursday don't have lab, so I'm not going to force the guys on Tuesday to have lab. So it's fall break. So, but if you have Mungia, she's meeting. So. Come by. I'll be here all day if you have some questions. I'll be here through 5 o'clock. I have meetings now, but tomorrow is Tuesday. Oh, we don't have lab. I have to check my schedule and see. I may have a meeting or something. I'll have to check, Monica. You can email me.